Section 11.2 is about arithmetic series. A series is an indicated sum of the terms of a sequence. Section 11.1 was talking about arithmetic sequences like you see here. There are two examples. When you take those terms of a sequence and you add them together, it then becomes an arithmetic series. So a series is just taking a sequence and adding them up. You see here the formula for the sum of an arithmetic series. There are actually two formulas. This is probably the one we'll use most often. What the different things mean here: a sub 1 is the first term of the sequence, and then a sub n is the last term of the sequence. S sub n is the sum of however many terms you're looking for, and then n over 2 is just the number of terms divided by 2. So we're going to use these formulas to find out the sums of arithmetic series. Here we're asked to find the sum of the first 100 positive integers. So if we think about the first 100 integers, we can say that a sub 1, the first value, is 1. We can say that the 100th value in that sequence, a sub 100, is 100 because the numbers go from 1 to 100. And then if you think about each number, you can say the common difference is 1. So you know that you have an arithmetic sequence. Now we're going to find the series, or the sum, from 1 to 100. So we'll start with this formula. This formula is useful if you know n, the first term, and the last term. So I'm going to say the series going up to 100, the 100th term in the series, equals n. N is the 100th number in the series, which is 100, divided by 2 times 1 plus 100. And then we'll solve that. So this is really 50 times 101, which is really 5,050. So the sum of the numbers from 1 to 100 is 5,050. Now we can do that a second method by using the other version of the formula. Here we have that other formula. This one you use when you know the D, and it has kind of the formula for an arithmetic sequence built into it. So again, we're finding S of 100 equals 100 over 2. And in this formula, we'll do 2 times the first term plus n, which is 100 minus 1. And the common difference is 1. So this is 50, again, times 101, which is the same value, 5,050. So it doesn't matter which version of the formula you use. If you know the D, you can use this one. If you know the last term, you can use this one. But both of them give you the same value for a series. So here we're asked to find the first 3 terms of a series in which we know the first term, we know the last term, and we know the sum. What we don't know is we don't know the common difference, and we don't know the n. We don't know what term we're talking about here. We don't know how many terms are in the sequence or what the last term is, and we don't know the common difference. And we need those two things, or at least we need the common difference, to find the arithmetic series. The problem is we can't find the common difference without the n, and then what we're going to do is use one of our formulas to find the n. So I'm going to start by finding n using this version of the formula, because I know S sub n is 741, so I know my series total is 741. I don't know what n is, but I know the first term is 9, and I know the last term is 105. So this is 114. If I divide that by 2, I'm going to get 57n. And then to isolate for the n, I divide both sides by 57. So our n value is going to be 13. Now that's important. The first thing I need to find is the n value. So now I'm going to use this n formula in another formula to find the d. So now I'm going to find the common difference. Now something that we haven't talked about in the series section, which is what this is the general form for an arithmetic sequence. So this formula is really all I need to find d. It's the formula for an arithmetic sequence. So a sub n, the last term in my sequence is 105. My first term is 9. I now know what the n is, so I know I can plug in 13, and I can use all that to find the d. So moving 9 over here, I get 96 equals 12d. Divide both sides by 12. So I can find the common difference is 8. Now with those two values, I can find the next three terms of the arithmetic sequence. So I know a sub 1 is 9, a sub 2 is going to be the 9 plus the common difference of 8, so a sub 2 is 17, and then the third term of the sequence is that 17, again plus the common difference of 8, which is 25. So the first three terms of the sequence, 9, 17, and 25. Now here we're going to look at something called sigma notation, which is a more concise way of writing out a series. Here's an example of a series, and we use the Greek letter sigma. You see that here, it looks like an E. That's the Greek letter sigma. We use that to represent a series. And in this case, it's saying that the letter n is going to go from 1 to 10, which means there are 10 values in the series. And the way you find those 10 values is you put the index, the value for n here, in for n. And then you find that. So when I plug a 1 in for n, I get a 3. When I plug a 2 in for n, I get a 6. So the third value of the sequence is a 9, and so on. And then the sigma, the Greek letter, means I'm going to add these all up. The index of summation in this case is the variable that we're using, the variable n. That's just called the index. So this is a nice way for us to write out series in a very concise manner. Okay, so here we're asked to evaluate a series. This series uses the letter J, and J starts with 5 and goes to 8. So we're finding the 5th, 6th, 7th, and 8th term of the sequence. And the way we do that, well, I'm going to do it two ways. I'm going to do it one way, long way, just to show you how it works, and then the second method I'm going to use is using a formula to show how easy that could be. So we're going to start by taking 3 times J. Now I'm going to start with a J of 5 minus 4. I'm going to take that value, and because it's a series, I'm going to add it to the next term, which is taking the same thing, but instead of a 5, I'm plugging in a 6 now, 4J. And then the next one, I'm going to add that to plugging in 7 for J, and I'm going to add that to plugging in 8 for J. So that's what's going on. We're using 3J minus 4 with the index variable, plugging in a 5, a 6, a 7, and an 8, and we evaluate that whole thing to find out what the summation is, or the series is. So here we find 11, 14, 17, and 20 all add up to be 62. So that's one way you can do this. You actually plug the values 5, 6, 7, and 8 into the expression, and you add them all up. The other way is to use our formula. Now, because we're plugging in the numbers 5, 6, 7, and 8, there are 4 terms, so we're going to find the series of 4 terms. So we'll take 4 divided by 2. The first term in the series is going to be 11, because when you plug 5 in, you get an 11 here. And then if you take 8 and plug it in for J, you're going to get 24 minus 4, which is 20. So you can find the last term in the series. And so this is really a 2 times a 31, which is still a 62. And so either way you look at it, you're going to get a 62. If you can find the first and the last term in this series, this is probably the way to go. If you're only asked for a couple of values in a series, this is okay. But imagine if you had to add up 100 of them, you certainly would want to use the formula.